the inverse of a function is so that if we apply the inverse function to f of x, I'll get x back. So we have some intuitive ideas, right? Suppose that f of x multiplies x by 2. Then we feel that the inverse function should be divide whatever you have by 2, right? We write it as f. The inverse should be division by 2 because that reverses the multiplication by 2, right? So the usual trick is when I have f of x equals something, say x plus 2 divided by 5. To find the inverse function, I'll call this guy y and solve for x. So what I mean is I'll try to move everybody that's not x to the other side. So I'll have 5y equals to x plus 2. And then I subtract 2. I have 5y minus 2 equals to x. So this is my inverse function, which I'll write it as g of y is 5y minus 2. So the inverse of adding 2 and then dividing by 5 is multiplying by 5 and subtracting 2, which feels reasonable.
Yeah.
In this case, because it's easier, it's a linear equation, so we can see like, okay, I added 2 and then I divided by 5. So to reverse this, I need to multiply by 5 and subtract 2. So that's going to be inverse, yeah. But it works for more complicated stuff, right? So the same idea. If I have, I start having things like this, like, yeah, x minus 5 squared, and then plus 1. What do I do now? So I call this guy y, and then try to isolate the x. So same idea as before, except now our function is a little bit more complicated. So I'll subtract 1, and then I'll take the square root for everybody. So you need to check the domain so that you can actually take the square root. So there's that, but we can just say, okay, take the square root of everyone, and then now add 5. So this is my inverse function. So that's how we calculate the inverse. Here you have a domain issue, right? Domain problem because of the square root. You have to be careful of that.
Right. And x stays on the opposite side that it normally would.
Yeah, you just need to isolate it. So I did it this way so that I don't have to keep switching sides, but I'm just moving everybody that's on x to the other side. And once I finally get x back, then this expression for y is going to be my inverse function.
Right. That makes sense.
And so it means that when I do f and then I do g on this, I get back my original x. It's clear to see from these ones, right? When we multiply by 2, so you got to divide by 2. You subtract 5, so then you have to add 5. So that's how to reverse what you did to the x.
Right.
So that's it. That's 7th objective.